We're back in our Arduino IDE, and we're just going to resave this, but as a new program. So we'll go save as, and we can just name it button sample 2 or whatever you'd like to name it. Notice it changes there, and it'll create a new folder for you to store all the appropriate files. So in button sample 2, I need to make a few changes to our code. The first thing I need to do is I want to create a variable that is accessible. Now, I could create this, in this case, most anywhere, but I'm going to go ahead and create it as a global variable. That is to say, a variable that can be used anywhere in the program. So I'm going to want to create a variable that lets me keep track of whether or not the switch has been pressed. So remember what we're going to do in our second design challenge is we're going to use the button as a switch that, like, when it's pressed once, it turns the light on, and the light stays on until we press the button again to turn the light off. So to do this with a digital push button, we need a variable to keep track of the current status of the light. So the easy way to do that is by using a simple numbering system. So we'll create an integer, we'll call it switch status, and we'll give it an initial value of 0. So what we just did was create a holder, a variable that we named switch status, and we initialized it with a value of 0. Now, the other thing we want to do, we're going to leave the wiring setup the same. So our pin modes in code line 4 and 5 shown on the screen aren't going to change. But we do need to change, we do need to add one other feature. We want to make sure that the current status of the light at the initiation is what we expect. And that is, we'd like for it to start by being off. So we'll say digital write 3 is low. And the reason we want to do that is we've said the switch status is 0. So I'll add a comment here to remind myself. We're going to say 0 is LED off. So we want to make sure that since the switch status is 0, this is making sure that the LED is off. So that helps us make sure that our variable value is lined up with or aligned with the current status of the LED before we get into our void loop. Now, we're still going to be pushing a button. So this idea of doing a if digital read equals low still holds. This is still going to look to see, that's still the code we're going to use to see, was the button pressed? But pretty much everything after that, we've got to think a little bit differently. So we're going to get rid of the rest of the stuff that's in here for now. So this is still our shell if the button was pressed. And I'll just make a little comment here to remind us. This checks to see, was the button pressed? So now, if the button was pressed, we now have to look at something. We've got to make a decision. Should the light turn on? Should we write a signal of high to pin 3? Or should the light turn off? Well, to make that decision, we need to know what the current status of the light is. That's why we're using that variable at the top. So we're going to say, inside of this if, the first if, we're going to say if, and in this case, we want to look at the value of switch status. If that variable switch status has a value of 0, meaning if the light is currently off or was off when we press the button, then what should happen? Well, we want a digital write to pin 3, a high. We need to turn on the light. Else, so in other words, if the switch status was 1 or the light was off, then we need to do something differently. So else we want to digital write, so the light was already on. We want to write digital write 3 to low, pin 3 to low. But we've made a little bit of an error here. This would all work, but it would only work the very first time because we're not changing the value of switch status. So when we turn the light on in line 12, we need to add another line of code here that says switch status now equals 1 because now the light's on. It just turned on in line 12. Similarly, we don't need a parentheses. Similarly, after line 16, since we just turned the light off, digital write to pin 3, we turned low, so we turned the LED off. We need to store that new status for the light in our variable. So we'll set this back to 0 because the light is off. Now, you may notice in the code, we've added a brief delay before we leave. So you'll see there's this delay. I think we did 150 milliseconds. So we did a 150 millisecond delay. That delay is just to it's to help us with something called debouncing. So the reality is we actually stepped through this loop very quickly, something like 30,000 times a second, extremely fast. So it's constantly looking to see, hey, did we press the button? Did we press the button? Remember, that's how we trigger our initial if. Was the button pressed? Was the button pressed? Was the button pressed? But it's asking that question about 30,000 times a second. When you press the button, it feels like you just pressed it once. But because it's reading so quickly, it will read an unintentional 5 or 10 or 30 or 50 presses of the button when you think you've just pressed it one time. So to account for that, we put a brief delay in on this loop check. It's 150 milliseconds. It's very slow, or very, very fast delay. So a brief delay, we'll never notice it in real time, but it allows the Arduino to avoid misreads of thinking we've pressed the button, multiple times when we really only intended to press it once. Okay, let's save that work. We'll upload that and make sure we don't have any syntax errors. Okay, that uploaded properly. So now we'll jump back to our breadboard and make sure it works as expected. So we'll press the button and make sure it works as expected. Once to turn it on, once to turn it off. And again, that seems to be working exactly as we hoped. Thank you for participating in this week's design challenge. If you'd like videos and tutorials or documentation for the projects we're doing, all of those links are included in the description below, as well as tutorials for how to do this exact same project with microbit using the same sensor kit. We've also provided links to the sensors and each of the hardware components that we're using in the video, so you're welcome to follow along. Finally, as always, we make these videos primarily for teachers and students to give them an introduction to electronics and microcomputing. We know there's lots of ways to do this kind of work. If you have ideas, insights, comments, please include those in the comments section below. We're interested in growing together as a community, and your input could be incredibly valuable for someone else. Thank you.